Hi friends, welcome to Neetsuccesstips YouTube channel. I am Lion Srinivas, teacher, Lions Club past president and June chairman. I am uploading daily Neet or EAMCET or JEE related topics, that physics, chemistry and biology topics I am uploading. NCERT books from I am taking the important questions from NCERT books. So earlier I uploaded biology first year 2 videos, second year 2 videos, chemistry first year 2 videos, second year 2 videos, and also physics first year 2 videos, second year 1 video. Today I am uploading second year video second. So if anybody have not seen previous videos, please go to my Neet Success Tips YouTube channel and watch and learn the easy tips and techniques. So by watching that and to remember the techniques, you have to think your own way also. If you like my tips, you can proceed. Otherwise, if you thought any other keyword, you write that word in your notes or on the book itself. So don't by heart anything. Use creativity learning method. Then only you can remember while answering the questions in the in your actual exams. So please learn with creativity and be patient and do hard work. Then you will get success. So if you like my videos,
please like, share, subscribe and click the bell icon.
Thank you. We'll move to today's topic. Neet JEE EAMCET Physics Second Year Video 2 questions with easy tips and easy memory techniques. Match the following physical terms with its formulae. So these are the physical terms: wave number, wave velocity, wave frequency, wavelength. So V into lambda, C by lambda, V by C, C by V bar. What is the answer? Answer is 3. Wave number. Wave number is equal V by C. Wave number is equal V by C. Next, B1. Wave velocity. Wave velocity is equal V lambda. V into lambda. Wave frequency. Wave frequency is equal C2. C by lambda. Next, wavelength. Wavelength is equal C by V. D4. So C is the answer. So we'll move. C is the answer. Wave number. So 1 is 3 V by C. So what is the formula definition? the number of waves or cycles per unit distance or length. Wave number is the number of waves per cycle or per cycle per unit distance or length. Or in another meaning, the reciprocal of wavelength. Wavelength we know lambda is equal to c by v. Lambda is equal to c by v. Wavelength is the letter is lambda denoting wavelength. Lambda is equal c by v. Okay, c by v. So you can remember first wavelength. Wavelength c by v. Lambda is equal c by v. You can remember cinema, movie. So cinema and movie. Okay. Cinema or movie. So cinema divided by movie. C by v. Like that you can remember. Wave length. Cinema have some length. 2 hours of 2.5 hours. Or some movies 3.5 hour length na. So you can remember like that. Wavelength. Cinemas, movies are length. Serials are only half an hour. So cinemas, movies are length. Wavelength. Lambda is equal C or V. Cinema or movie. That is nothing but C by V. The reciprocal of wavelength is equal wave number. C by V. Reciprocal means reverse. V by C. So reciprocal is V by C. That is the answer. The units are per meter or per centimeter. The reciprocal of wave length na. 1 by wave length is cinema or movie. So C by V. Reverse V by C. So answer is V by C. Like that you can remember. Wave velocity. Wave velocity. You take that V into lambda. Simple. Wave velocity. You multiply that V into lambda. V means this is small v. So frequency into lambda. Wave velocity, this is big V. Velocity means big V, but you have to take small v. So small v into lambda. What is the definition? The distance covered by a wave in unit interval of time. The distance covered by a wave in unit interval of time is called wave velocity. So this is capital V, this is small v. Frequency into lambda. Lambda means wavelength. Centimeter per second. Next, wave frequency. Wave frequency is equal C by lambda. Wave frequency. Okay. Frequency we will watch movies. So, or movies are that cinemas are belongs to lambda na. So you can say lambda. Frequency is equal like this. Frequently we see movies by this y reverse y lambda. Like that you can remember. Frequency cy. You remember keyword is you take cy. Wave frequency you take cy. Frequency c by reverse of y lambda. Simple na. Wave frequency is equal last two letters cy. C by that we are reversing. So that is why we are taking division. Division. So reverse. Reverse means it go down. Y reverse lambda. Like that you can remember wave frequency. Wavelength already we know. We go length cinemas or movies, V like that. Here units is angstrom units. 1 angstrom unit is equal 10 to the power of minus 8 centimeter. 1 angstrom is equal 10 to the power of minus 8 centimeter. 1 nanometer is equal 10 to the power of minus 7 centimeter. Okay? Like that you can remember. Angstrom has 8 letters. ANGSTROM. Angstrom. Angstrom is 8 letters. ANGSTROM. Angstrom 8 letters. So, to take minus 8, 10 to the power of minus 8 cm, 1 nanometer. So, you would add 1. Minus 8 plus 1, minus m, minus 7. Like that, we can remember. In other sense, n is 14, m is 13. 14 means 5, 13 means 4, 5 plus 4, 9. So, 9, it's not coming any relation. So, you like remember this 1 angstrom minus 8, 1 nanometer minus 7. Okay, adding plus 1, minus 8 plus 1, minus 7. Like that you can remember. The distance between two successive crests are throw. Wavelength is the distance between two successive crests are throw. What is the crest? The waves are going up and down. The up part is crest, low part is depth, depression part is throw. Waves are going up and down like that. So the up part is taking crests. The lower part is depression part is called throw. Okay, two successive. Here also successive we are taking minus 8, next successive minus 7, minus 6, minus 5, like that 0, 1, 2, 3 now. Two successive crests like that. Here 1 angstrom, 1 nanometer. We are taking successive centimeters. That is one keyword. You can remember like this also. Amplitude is another one. I have given extra. Actually, there are only ABCD options in there, but I explained amplitude meaning also. The definition is the maximum height of the crest or maximum depth of the trough, whatever may be. The maximum height of the crest. The waves are up and down now. So you take the maximum height of up or maximum depression or depth of trough. That is called amplitude. The answer is the height means distance. The units are angstrom units or meter or centimeters. Whatever you want, you take. Next second question. Match the following physical terms with its formulae. Radiant flux, radiant power, radiant flux or radiant power. Both are same. Luminosity or radiant flux or luminosity of radiant flux or radiant intensity. Both are same. Luminous power flux or luminous flux of source. Both are same. Luminous intensity or illuminating power of source. So you have to match with these formulas. So first you remember in mind because all options A, B, C, D and 1, 2, 3, 4 we can't see in one screen. First you remember in mind what is the formulas. After I will show the options 1, 2, 3, 4. Okay. And I have minimized screen. Now you can see ABCD options with 1, 2, 3, 4. Come on, do fast. What is the correct option? You match with ABCD with 1, 2, 3, 4, right? On a paper or in notes. Later I will show the ABCD options, which is correct. Okay. What is the answer? Answer is B. A1, B2, C3, D4. We will see the total, the definitions and keywords. The first one is radiant flux. A is 1, E by T. So radiant flux means phi E. Radiant flux is phi E. Simple radiant flux. Here 4 letters starting with the letter F. So you remember radiant flux. You take like keyword is 4. F-O-E-R 4. Here 5. F-I-V-E 5. 5. 5. F-I-V-E-E. 5E is the denoted by radiant flux. The symbol of radiant flux is flux 4. This is 5. So 5 F-I-E is equal energy emitted by time. Energy emitted means Q by time. So joule per second. So energy is formula joule now. Work or energy. What is the formula? It's joule. Actual work formula is force into distance joule. Here is that I am taking energy. Okay. The letter is I have taken here Q. So joule. Joule per second or watts per meter. Meter watts by per nanometer, like that. Any units you can take depending on the question. Definition: the time rate of flow of radiant energy. The time rate of flow of radiant energy. Radiant flux means radiant energy. So the radiant energy emitted is Q by the time rate T, or it is the total amount of radiation or total power of limited light emitted. You have to remember this main light emitted through a given area on the earth. It is the total amount of radiation or total power of light emitted, radiation or light emitted through a given area on the earth, and its atmosphere absorb, convert into heat and re-emit. So that is called radiant flux. Energy emitted by time. radiant power P by 5. So that is Q by T. Okay, Q by T, dQ by dt watts. That is also another formula. dQ by T or dQ by T. Next, luminosity of radiant flux or radiant intensity. Phi E by theta. Luminosity of radiant flux or radiant intensity. Phi E by theta. Phi E means 5 radiant flux symbol. Radiant flux by solid angle. Radiant flux by solid angle. Radiant power or radiant flux of source by solid angle. The denoted letter is luminosity of radiant flux or radiant intensity is LP. So luminosity L, the radiant flux or intensity. So we are taken P. So the radiant power or radiant flux of source by solid angle. Here power is there like that. We have taken LP. So that is radiant flux. Phi E 5, flux is 4. Here 5 phi E by solid angle is theta. Watts per steradian. Watts per steradian. Because here radiant power is watts, theta is steradians or joule per meter square. Radiant flux intensity definition is it is the amount of radiation measured on earth by the time the radiation reaches earth. It will have spread out a great deal, therefore it will be only a fraction of the value of illumination. Intensity of radiation. It is the energy associated with photons. Intensity of radiation. It is the energy associated with photons and or other elementary particles emitted from a unit surface area in unit time. Luminous power or luminous flux of source. LE by T. LE, just now we learn luminous energy emitted. LE. L means E, energy emitted E by time. So luminous power or luminous flux of source is 5E flux 5. So luminous energy emitted by time. Units are luminous power or luminous flux lumen. Okay, or candela into steradian. 1 lumen is equal candela into steradian. 1 lumen is equal candela into steradian. So lumen or is equal candela into steradian. Luminous flux or power, the time rate of flow of luminous energy emitted from a light source expressed in lumens. Luminous flux or power, the time rate of flow of luminous energy emitted from a light source, it is expressed in lumens. That luminous flux or luminous power in expressed in lumens units. Radiation flux is measurement of all electromagnetic radius emitted, including infrared ultraviolet and visible, the radiant energy per unit time which is emitted. That emitted is including infrared waves, ultraviolet waves or visible waves. Emitted or transmitted or reflected or received by an object. In case of light, it is simply called the optical power. If the object is light, it is simply called optical power. Illuminance formula. Here see definition of illuminance. It is a luminous flux of one lumen falls uniformly on an area of 1 meter square. The further away the area is from the light source, the lower the illuminance. It is the luminous flux of one lumen falls means down uniformly, continuously on an area of 1 meter square. The further away the area is from the light source, the lower the illuminance. So if luminous flux or lumen of one lumen falls down, automatically illuminance also lower. So illuminance is equal to 1 lux. 1 lux is equal to luminous flux by area. Luminous flux is equal to illuminance into area. Reverse. Luminous flux is equal by area. This is go to top. Multiply with numerator. Illuminance into area. Depending on the formula. Find illuminance, you take luminance flux by area, or find luminance flux, you take illuminance into area formula. Luminous power or luminous flux. It is the measure of perceived power of light. Luminous power or luminous flux. It is the measure of perceived power of light. Earlier is emitted power of light. Here power, luminous flux or luminous power, perceived power of light. Earlier, where is that emitted in bold letters? For this one, radiant flux. For radiant flux, the, the radiation or total power of light emitted through a given area. Emitted. Radiant flux is the radiation or light emitted, radiation flux. Here, here earlier radiant flux. Here luminous flux or luminous flower. It is perceived power of light. There is emitted of light. Here perceived power of light. That is the difference you have to notice. Like luminous energy. It is the perceived energy of light. Luminous energy means it is the perceived energy of light. Units is lumens per second. Luminance is equal to already we learned 1 lux is equal to luminous flux by area, or reverse we can take luminous flux. Luminous intensity or illuminating power of source phi E by theta. 5 is radiant flux by solid angle. 5 4 means flux, radiant flux by solid angles. Luminous intensity, it is the quantity of visible light that is emitted. Okay, this is about second question. Now we will move third question. Match the physical terms with its formula. Intensity of illumination or luminance, relative in luminosity, luminous efficiency, illumination or luminance. The 1, 2, 3, 4. Here we can take capital line. IV by D square. Okay, what is the answer? Answer is A. So, A4. IV by D square. Intensity of illumination or luminance. IV by D square. IV. Luminous intensity. IV means luminous intensity. In earlier question, we learned by distance square. So intensity of illumination is called that illuminance. So luminous intensity by distance square. In question answer is there. Intensity of illumination or luminance. Luminous intensity by distance square. So candela per meter square, lumen per steradian into meter square are the units. Next, relative intensity, relative luminosity. So that is keyword used by letter relative luminosity is Y. Y is equal L1 plus 0.05 by L2 plus 0.05. Luminous relative luminosity. That is luminous flux of source of a given wavelength by luminous flux of peak sensitivity wavelength. Both are same. So L1, L2 both are same units. L1 and L2. So finally there are no units for relative luminosity. Here L1 greater than L2 it should be there. Luminous efficiency. Luminous efficiency 5V by P. 5. 5 is equal flux 4. Radiant flux by power. So lumen per watt. Illumination or illuminance. Illumination or illuminance. 5 by area square. 5V by area square. Luminous efficiency and illumination difference is only the denominator. Efficiency is P, power. Next, only illumination is area square. That is the difference. One illuminance is 1 lux. If luminous flux of 1 lumen falls uniformly on an area of 1 meter square. So that is the answer. We'll move to the next question. Match the following physical terms with its formulae. Mass defect, binding energy of nucleus, decay constant, resonance frequency. Mass defect is delta M. Mass defect is delta M. I have given a clue. So all M's are here. Delta M is here. This is not. This is his decay constant. This is resonance frequency. So answer is C. A4. Mass defect is mass of atomic unit minus mass of protein plus mass of neutrons. Binding energy of nucleus B1. So mass defects into C square. Mass difference into speed of light. C means speed of light square. Decay constant. Constant value by half-life. 693. All are multiples of 3. 3, 3 2 ja 6, 3 3 ja 9 by half-life. Next, resonance frequency 1 by under root L into C. L means luminance, C means speed of light. Like that, you can remember. Next, fifth. The time required by the electron to fall through a distance is h is the time required by the electron to fall through a distance h is so answer is C, square root of 2 into h into me. So here you remember like hm headmaster. So if you late come to school within time, you have not come within the time, so he will give some punishment. Okay, so your energy will last like that. So 2 energy, double energy loss like the 2hm headmaster E, like that. If start in any other way, you can remember like that. This is my keyword, my thought. Match the physical terms with formula. Electric field of dipole at a point on the dipole axis. Electrical field of a dipole at the point of on the equatorial plane. Here is on the dipole axis. Here at the point on equatorial plane. Gauss law. Electric flux through a closed surface S with total charge. Here Gauss law. Consider a point outside the shell with radius vector R. Calculate E at P. Some point P. P is outside point. We take Gaussian surface to be a sphere of radius R and center O. So this is sixth question. So match with ABCD with 1, 2, 3, 4. What is the answer? This is some tough questions. That's why I'm giving time. Think. Confused definitely. So electric field of dipole at a point on dipole axis. So 2p by 4 pi epsilon 0 RQ A4. So electric field E is equal to field of dipole at a point on a dipole axis. So dipole axis. So 2p by 4 pi epsilon 0 RQ equatorial plan, that is minus p by 4 pi plus epsilon 0 RQ equatorial. At equatorial our weight is very low. So that is why I am taking minus, like that you can remember. Here 2p, here half p. Weight is low. If you go at equatorial, you can weigh, your weight will decrease. So decrease means minus. 2p is called p. The balance is same, like that you can remember. Next, Gauss law. Electric flux through a closed surface S with total charge. And Gauss law, consider a point outside the shell, vector v, radius vector v, or calculate E at P. We take Gaussian surface to be a sphere of radius R and center O. So what is the answer then? What? Phi is equal Q by first electric flux through a closed surface S with total change is phi is equal to Q by epsilon 0. Next, sphere. If you take sphere, E is equal Q into R by 4 pi epsilon 0 R square. Here you remember, here RQ, here R square, same 4 pi epsilon. You remember, here P, after PQ come now. P into that sphere of radius R. Sphere radius R I have multiplied with Q into R. Above Gauss law is same, Q by only epsilon I have taken. Q epsilon 0 I have taken. Like that you have to comparison, you can remember. Only single formula you can't remember. You have to compare with one formula to another formula. Then only you can remember easily. So Coulomb law, Gauss law. Three Gauss losses are there. Thin spherical shell, infinite thin place, thin infinitely long straight wire. You have to find the charge density. First one is Coulomb law. First one is Coulomb law. So what is the formula of Coulomb law? What is the formula of Coulomb law? Coulomb law form is 3. A3. F21 is equal K into Q1 into Q2 into R21 by R21 square. F21. Coulomb law is F21. Here R21 R21. So K into Q1 into Q2 what? 2 points charges Q1 and Q2. Coulomb law is the mutual electrostatic force between two point charges. The mutual electrostatic force between 2 point charges, this Q1 and Q2, is proportional to product and inversely proportional to the square of the distance R21. Like that, you have to remember. F21 is equal to K into Q1 Q2 into R21 by R21 square. This is R. This is R bar. That is why we can't cancel. Both are different terms. Okay. R bar 21 is a unit vector in the direction from Q1 to Q2. What is K value here? 1 by 4 pi epsilon. K value is 1 by 4 pi epsilon. K value. You have to substitute. Epsilon 0 is equal to what? 8.854 into 10 to the power of minus 12. Approximately K value is 9 into 10 to the power of 9 Newton meter square per Coulomb square. Next, B1. Thin spherical shell B1 is equal to lambda into n by 2 pi epsilon r. Infinite thin. Thin is lambda and 2 pi epsilon r. Next, C2. F is equal to rho into n. Here is lambda. Thin means lambda. Infinite means rho into n by 2 pi epsilon 0. 2 epsilon 0, not pi r. Here not taken pi r. Next, D4. Epsilon is equal to q into r bar by 4 pi epsilon r square. Thin infinitely. So thin infinitely means sum. 2 plus 2, 4. 4 pi. Pi I am taking extra. Epsilon r square I have taken extra. Only thin means r. Thin infinitely means r square. Like that you have to remember. So for this type of questions you have to put light simple techniques and you have to by heart also. That is why I told you have to use some 20 to 25% by heart method for some problems and use 75 to 80% creativity learning method. That is the only thing we can do. Nothing else. Next, what is the potential energy of a system of two charges? What is the potential energy of a system of two charges? Potential energy of a system of two charges. So answer is C. U is equal to Q1 into Q2 by 4 pi epsilon R12. Okay, here Q1 Q2 multiply by 4 pi epsilon that 1 2 R12. So 4 pi epsilon 1 by 4 pi epsilon is equal to K. K value is 1 by 4 pi epsilon. Or you can say K into Q1 into Q2 by R12. Simple formula. No squares, no cubes. Only simple R. Potential energy of system of two charges. So two charges, one, two charges. Like that you can remember. Match the following different types of electromagnetic waves with its wavelength ranges. So different type of electromagnetic waves are there. Microwaves, ultra waves, ultraviolet, infrared with its wavelength ranges. Fourth one is light wave. What is the answer? So ninth question is B is the answer. So here A2 microwaves 0.1 meter to 1 millimeter. Next B3 ultraviolet means 400 to 1 nanometer. C1 infrared waves is 1 millimeter to 700 millimeters. D4 light waves to 700 to 400. Here all this compared to which is very less, nanometers are very less. Okay. 3. What is 3? B3. Ultraviolet waves are very low. 400 nanometers to nanometers. Like that you have to remember. The first ultraviolet rays. 400 nanometers to 100 nanometers. Ultra. You can write U like one line. If you write one line to the U like this 4, it will come 4 now. U, I am writing one line U here down. So that looks like 4. So like that you can remember 400 nanometers to 1 nanometer. Next is 1 now. So 1 nanometer. 400 nanometers to 100 nanometer. Next, microwaves A2 zero point 0.1 meters to 1 millimeter. It is high. Meter is millimeter, meter greater than millimeter. So all these high waves are the microwaves. Light waves are ultraviolet. Okay. It is it is you. I am high, you are some low value. Like that you can remember. So my means I self. Microwaves are greater. So 0.1 meter to 1 millimeter. So 1, 1. This is 0.1, this is 1. Like that we can remember. Infrared means infrared C1 1 mm to 700. Infrared waves 1 mm to 700 waves. So total 1 plus 7 8. Infrared has 8 letters. So infra I have taken 1 mm. The balance are 700 mm. Okay. Infrared I looks like 1. So 1 mm to reverse of W M na. So that 1 mm to the balance letters 7. Except I 7 letters are there. N, F, R, A, R, E, D, A, 7. So 700 mm. 1 mm to 7 mm. Next light waves D. D4. 700 mm to 400 mm. So see, infrared ends with 700. Light waves start with 700 mm to 400 mm. Like that you can remember. Infrared light waves. Light will white color, some lights in red color na. So infrared light waves, compare like that. So infrared ends with 700 mm. Light waves starting with 700 mm to 400 mm, which is have ultraviolet starting with 400 nm. This is nm, nanometers. Here mm, millimeters. That you have to remember. By practice for some time you can remember easily. Match the following physical terms with its formula. Dielectrical constant of a substance, the capacitance of parallel, total capacitance in parallel combination, total capacitance in series combination. It is very easy. His answer is 1, 2, 3, 4. A. Answer is 1, 2, 3, 4. C. Dielectric constant of a substance. Epsilon by epsilon 0. So, di I am taking by. By means 2. Same, both are same. Epsilon by epsilon 0. Epsilon by epsilon 0. Epsilon 0 is what? Permittivity of vacuum now. Epsilon 0 is permittivity of vacuum. Only epsilon is strain or pressure. So, dielectric constant of a substance is epsilon by epsilon 0. Epsilon 0 is permittivity of the vacuum. Epsilon is strain or stress or pressure. Strain, not stress, pressure. Stress is equal to pressure. Strain is different. So, Strain is different. That is epsilon. Answer is delta x by x. That formula. Strain. Second one is the capacitance of parallel. Capacitance for parallel. So epsilon 0 permittivity into A by D. Next, the total capacitance in the parallel combination, series combination. So in parallel combination means parallel lines. Two lines are parallel, like. One line is like parallel and the down same line. So same line you have to taken. C is equal C1 plus C2 plus C3 plus C4 dash dash dash. So parallel means straight lines, parallel. One line under same one line. That is same one line I have taken. Series means the divisions 1 by C1 is equal 1 by C1 plus 1 by C2 plus 1 by C3. So this is called series combination. Like that you can remember. Match the following formula, physical terms with its formula. Dielectric constant of substance, the capacitance for parallel, the total capacitance in parallel combination, the total capacitance in series competition. Both are same, repeated. Okay. See. Next question. Match the following substances with its specific heat capacity. Match the following substances with its specific heat capacity. Heat. Specific heat, not heat capacity. Specific heat capacity. Wood, glass, lead, silver. Here some answers are given some wrong. So I'm changing. So now you observe. So what is the wood specific heat capacity? So it is 700. Wood. It is 700. Who I am taking? Who? Who means here 17 means Q. Q. Who? Q. Wood means nowadays forest is in forest many trees are cutting. They are after cutting they placed in a queue. So one by one. So the wood what will you do? The wood poles will like a queue means one by one. That wood poles, they will set one by one line in a queue. Like that you can remember woo, queue. In Pushpa cinema, you can see the wood poles. How can they set? Here is one pole, after on the top, another on the top, another on the top, another, like that they will set in a queue method. So queue. Next, glass. Glass is B3, 840. Glass is 840. So G. I'm taking G, glass. Guard. Guard is keyword. GOD. So G plus 1. I'm taking guard. But here I'm taking G plus 1. 8. 8. Guard. O. Last I'm taking D means 4. Like that you can remember. Glass. Guard. So G I'm taking G plus 1. 8. Here O is there. D is 4. Like that you remember. Lead. Lead is 130. So after L, J will come. I, J, K, L, M. So MO. Lead. Who will lead? No sir, I don't lead. No. Here Mo. Who can lead this team? All will say no sir, I can't lead, I can't lead. No, no, no. Here Mo. Mo. Like that you can remember. Silver is 230. Silver is 230. So silver, if you purchase silver, they will weigh it. They will weigh how many grams are there? Weigh. So weigh means like this. W 23. So the weighing machine is this shape. Round shape. The weighing machine is round shape. Or you can made a ring, silver ring, like that. So 230 is the answer. Like that if you put codings. By thinking many thoughts will come. Only thing is you have to observe for some time. That is called you have patience and do hard work with creativity learning. So put some keywords or techniques. At the time of exam, you can observe the answers easily. You can find the answers. You can remember easily the coding techniques in your mind. Okay. Thank you one and all. This is for physics second year, some important questions. So please watch my videos, earlier videos also, and practice. If you have enough time, you can one more time you watch. Then you can easily the techniques and keywords and write that keywords into notes or the book itself. Then in before exam you can revision easily. The time you can revision in less time. So automatically using the easy tips and keywords, it will help more. We can answer fast. So the time you can save the time. In the time you can solve the physics and chemistry formulas. That will take more time. So in the physics starting 4 videos I explained all formulas. Approximately 100 formulas I explained. Total. In some more problems are also formulas are also there, but I explained total important formulas with easy tips and techniques. So if you remember that, you can solve any type of problem after observing the problem given in the your examination. So while you reading other information also, please you have patience and do hard work with learning creativity method by putting easy tips and keywords. Then only you get success. You get rank in the Neet or JEE or EAMCET, whatever may be. Okay, thank you one and all. Jai Lainism, Jai Jawan, Jai Kisan, Jai Hind.